Hello, everybody. This lesson is about compound interest, but actually, by the end of it, it will be about the number e that we've been using. Like pi, e is a number with a decimal expansion. Pi is approximately 3.14, and e is approximately 2.71. But just like pi, it has an infinite decimal expansion that doesn't repeat. Pi isn't just a number, it has a human meaning relating to circles, measurements of circles. E also has a human meaning, and that's part of what we're going to discover by the end. Okay, so let's set the context here. So let's say we're investing money. So we've got $100 and we're going to invest at a whopping 100% interest. What that means is, and sorry, this is all compounded annually, and I'll tell you what that means. Compounded annually. So what that means is we start off with $100, and then at the end of 1 year, we get 100% interest, which means that we get 100% of our investment paid out to us. So we're going to take that 100% of $100, which is $100, and we're going to invest it again. So at the beginning of year 1, we've got 200. We've got our original 100 plus the 100% interest that we got, and we're just going to do that over and over again. So now, in the next year, from year 1 to year 2, we're getting 100% interest on $200. And then we'll get 100% interest on whatever we reinvest at year 2. Here, we have a much more reasonable 5% interest rate. So go ahead and kind of think through what would our total amount of money look like as time goes by, and see if you can use skills you already know to figure out what those equations are, or at the very least, what type of growth is happening here. All right, so I'm going to go through it now. So we get 100% interest on $100, add it to our original 100 to get 200. 100% of 200 is another 200. We'll add that 200 to our original 200 to get 400, and so on. So what's happening at 100% interest is we appear just to be doubling our amount of money every time. So if I wanted to write a general equation for this, money after t years, I think I could write 100 times 2 to the number of years powers. Now let's just make sure this makes sense. If I plug in t equals 0, 2 to the 0 is 1. 2 to the 0 is, right, this whole number becomes 1, and we'll get 100, so that works. You could spot check down here, or you could think in order to get from 0 to 3, we have to multiply by 2, 1, 2, 3 times. And this is literally saying multiply 100 by 2 t times. So if t was 3, we would be saying times 2 times 2 times 2. So this 2 to the t power is almost like instructions for saying, starting with your starting amount, how many times do you multiply by 2 to get to the row that's the year that you've described as your input. Okay, so over here, I'll need my calculator very soon. So 5% interest on $100 is $5. So now I've got $5. But now I'll need to actually figure out what's 5% of 105, take that and add it back. So let me bust out my calculator. Okay, we've done it. So here it's maybe a lot less obvious. You can't just look at the numbers and decide, oh, I'm multiplying. But perhaps you might guess that because this problem is a very similar context to this problem, we're multiplying by something. You might guess that. So how can we figure out what we're multiplying by? Let's think about it this way. 100 times mystery thing should give me 105. And if it's a consistent growth rate, or if I'm consistently multiplying by the same amount, that should keep working. So 105 times that same question mark should get me to 110.25. So what's question mark? Question mark is going to be 105 over 100, which is just 1.05. Or it should also be equal to, this 110.25 divided by 105, because I'm just using algebra here. I'm dividing by the 105 to isolate the question mark. And this also, if you plug it into your calculator, is 1.05. So just like this case over here, we're multiplying by 2. Here we're multiplying by 1.05 every time. Whoops. So I can write the equation down here in the same manner. I'll have 100, but now I'm multiplying by 1.05 to the t. Great, so we've got our two equations. And, that would be cool if you figured that out on your own. Let's go ahead and do this in general now together. Okay, so a little bit of vocabulary. Principal is the word used to mean some initial investment. And R is going to be the rate of return, which is the same as the interest rate. So if we're going to draw a little table here, and you should leave a lot of space off to the right because we're going to need to do some simplifying. We'll have years go 0, 1, 2, 3. Money, so we start off with the principal that we have invested. Just like up here, after 1 year, we'll have our initial principal plus whatever interest we got from that principal. So that's principal times the percentage, like the rate. So here when we had 100%, 100% is the same thing as multiplying by 1. 5% is like multiplying by 0.05. So you can sort of imagine we've got our initial principal plus that interest. What happens in the next year? So in the next year, actually let's simplify this one step. Well, no, let's not simplify it. Let's just do it. So the next year, we'll have the amount from the previous year plus whatever that made us in interest. So let's take that same amount of money, but multiply it by the return rate. Okay, and so you can see in the next year, we're going to take that whole amount of money, it stays what it is, and then we'll add the interest rate times that whole amount of money on this side. So it's like we're just going to get longer and longer and longer. So this feels like the kind of situation where we want to be trying to simplify and combine if we can. So one thing I'm noticing is here, I could have written this as p times 1 plus r, because I factor p out of each of these terms here. So if I do that, let's think about this. So let's, I'm going to erase this 3 and we'll try and simplify this. So this was actually p times 1 plus r, and then this is r times, this is again p times 1 plus r. Okay, so I'm noticing another thing. I've got two terms here. And there's a lot in common between the two terms that I could factor out. Why don't you see if you see it? It's going to be so nice. So I'm seeing both terms have a p times a 1 plus r. P times 1 plus r, and then here's p times 1 plus r. So let's take that p times 1 plus r and factor it out. So p times 1 plus r, so in this term, when I factor it out, I'm just left with 1, because that's all there was. On this right term, when I factor out the p times 1 plus r, I have r left over. So now I've got p times 1 plus r times 1 plus r. So put that all together, and we've got p times 1 plus r squared. Maybe you can start putting together what's happening here. So when t is 0, we have p. When t is 1, we have p times 1 plus r. When t is 2, we have p times 1 plus r squared. When t is 3, maybe you have a guess, might be p times 1 plus r cubed. We should justify that that's actually true. And hopefully you're thinking, if we're doing what happened up here in general, this equation should match with the form of the equation that we derived up here. So we should end by thinking it's something times something raised to a thing power. And that sort of is how this is feeling, something times something raised to a thing power. Let's justify this. Let's justify this using a strategy called induction. So we showed just using algebra that the function a of t here has this form for the first couple values of t. So it has the form something times something to the something power. So now let's sort of jump down the table. Let's say, so here's t, here's money. So let's say we are down the table to some year, let's not call it n, let's call it t. And then let's think what happens in the next year. So we're going to assume, for the sake of argument, that this pattern continues. So let's assume that the amount of money we have after t years is going to be p times 1 plus r to the t power. What we want to be able to show is that if this is true, then the next year is p times 1 plus r to the t plus 1. Okay, so let's derive this in general. Let's just apply what we know about interest. So in the next year, we'll keep the p times 1 plus r to the t, because that's how much money we had in the previous year. But then we're going to add in the interest. So the interest is r times that same thing. And now we'll simplify it. And we can simplify it the same way that we did before. Factor that out of both, and we've got p times 1 plus r to the t times this term becomes 1, this term becomes r, and so now we have another 1 plus r, just like the base here. So this has become 1 plus r to the t plus 1. Great. So what have we done? Our argument is in 2 steps. We showed that if a of t equals p times 1 plus r to the t for some t, then a of t plus 1 equals 1 plus r to the t plus 1. So we've shown, like, if this pattern is true for one step in the table, it will also be true in the next step of the table. And then over here, we showed that this pattern is true for some particular values of t. So it's not just, we're not just saying if it's hypothetically true that it's this form. We actually know that this is true for t equals 0, 1, and 2. And so if you put these 2 facts together, that shows that the entire rest of the table has to have that form. Because we showed it has that form for the first couple, and then we showed that if it has that form for 2, then it must have that form for 3. That was this part. And if it has that form for 3, it must have that form for 4. And if it has that form for 4, it must have that form for 5, and so on. So this statement that we did here, which was showing that if it works for one row, it's got to work for the next row, that's what proves for the entire rest of the table. Okay. So what have we shown? We've shown that a of t is in fact principal times 1 plus the rate to the t. So if that's true, does that really fit with the results up here? Why don't you take a minute and think about it. Is this really the same for there? Is this really the same for there? So up here it should be pretty clear. We invested a principal of $100, and then we've got 1 plus the rate. What was the rate? The interest rate was 5%, which is 0.05. So yeah, we have 100 times 1.05, because that's 1 plus 0.05 to the t. So that works. But this just says 2. How is 2 1 plus something? Oh, if the rate of return is 100%, that's just 1. So 1 plus 1 makes 2 to the t. So this general form does seem to work for both of those particular examples. Okay, why don't you play with this new toy that we found. So these are sort of like approximately true. If you just put your money in a bank in a savings account, for example, you'll get about 3% annual interest. That's actually maybe even a little bit high. If you invest in an index of stocks like the S&P 500, what that is it's like 500 stocks that are sort of like it's like the 500 largest companies on the stock exchange. Individual company stocks might go up or go down, but if you've invested in all 500 over time, your investment is going to do what kind of the whole market is doing. So if the whole market is going up, you will also go up. So if you invest in something like that, you might get around 10% interest a year. That's, I don't know, that's probably about right. Okay, so imagine that. Imagine you put $100 in at age 18. How much would it be worth when you're 50 if you're investing in the bank or if you're investing in the S&P 500? So go ahead and work out those two values using your equation. And then come back for video 2 on the backside.